on Twitter. So,
two things about ourselves. So
I'm known quite often in both the professional and chat circuit as the Def Leppard CISO, and I'm a huge gamer, and normally without a Def Leppard t-shirt.
This is true. And then I've been 15 years within IT and security. I'm also circus artist and gamer, which pretty much means I do crazy stuff in the air for aerial circus arts. All right, so this talk was spawned or conceptualized by you, I guess?
Yeah, I got asked a lot of questions about what exactly keeps me awake at night, where are all of the problems in the whole universe, and how could a CISO fix everybody's life, the universe, and everything, to where I answered, I have no clue.
So we kind of had a conversation about this, and we brainstormed and put a presentation on this, specifically with our experience within life sciences and scientific organizations particularly. Yeah. So I guess we kind of just formulated it down, distilled it down into the main topics, right?
Yeah, and what we tried to do is just look at actually within these organizations, and also a lot of our peers have helped us add some of the stuff here, is exactly what does drive the people and us to actually have big, huge security issues. And, you know, first thing, like everything in a research organization, and depending, especially in life science, everybody is trying to cure cancer and do something great, and that leads to good intentions, you know, and the good intention of bringing in a new application and not telling us about it that is totally vulnerable doesn't help us.
And again, so good intentions would be a big one. Again, you have to understand the mindset of this scientific research, and we're going to get into that.
Yeah.
Another one is, you know, typically ignorance. Oh no, it's fine. I bought it. It's good. We're all fine. Again, you also need to look into your population set within an organization, right? And we're going to kind of get into this. And these are individuals who are, as I called it, highly intelligent cats. And then you have other constraints like regulations, management, and budgets, and all of these together is what gives CISOs out there, particularly in life sciences, a lot of nightmares.
Yeah, and it's interesting because good intentions also comes very closely with ignorance, right? So it's been challenging for all of us in the ways, but you know, especially now with the current pandemic and all that stuff, budget and management. And then at a later date, regulations are going to come back. Yeah. People have forgot about that.
So what is this highly intelligent cat, right? So the way that I categorize it, and again, this kind of comes back from more of the regulation compliance side of me. I like to define terms. And these are individuals who are highly trained within a STEM or a STEAM field, whatever you want to call it, to solve very complicated problems, right? Curing diseases, determining satellite trajectories, doing stuff in space. Like a lot of these individuals have spent pretty much their career training, learning to solve very complex situations. And they have some characteristics.
Yeah, you're not going to find these characteristics in any books by Joe Navarro around this, because this is our characteristics of
based on our experience
in these fields. And just to give you a quick thing on these fields, the field is both life sciences and spacecraft operations.
So these are highly motivated individuals within your organization. They will do whatever they deem necessary to solve a problem or to not be blocked towards a problem. They learn things very quickly. So don't be surprised that a lot of your users are also multi-PhD owners who code and insert a language here, right? Yeah. And if they are given a constraint, they will think outside the box. They will find a way around it, because that is what you have been trained and you have gone to university and got all multiple PhDs to do, because that's what you're doing ultimately to solve these complicated problems. And then if all of this kind of resonates with everyone, hello, how are you, everyone? Yeah. Nice kitties out there. We fall into this, pattern and profile.
And most hackers, crackers, security researchers actually fit very much into the highly intelligent cats. We have a lot of the same traits that the scientists or the flight dynamics crew have. So we quite often have we don't want to slow ourselves down because research needs to go forward. Security research, life sciences research,
and so forth. All right. So we're going to get a little bit into, again, some definitions. Everyone here should know what this is. But again, if you don't, or if you're new or you're young, I don't know if this actually is taught within university or not. So we're going to define the CIA triad or the CIA principle. So go ahead.
And there's a reason for it, because you'll see as we go through these slides, companies look at this completely differently, right? So, as we go through, you'll see why we just quickly wanted to give a view of this.
Yep. So everyone should know this. One thing to note, these are not Boolean values. These are spectrums.
Yeah.
So in real life, again, these are not Boolean. These are spectrums. There's not a one-size-fits-all to an organization when it comes to the CIA triad or CIA principle. Contrary to what vendors will ever sell you or whatever you might hear, organizations are the summarization of peoples and processes, and people are very complicated. Processes, again, can be complicated, but because of that, every organization is different.
Yeah, and when you go into every organization, the culture is what drives that organization for success, right? And also understanding that cultural mindset is what helps you as a security professional actually be successful. Because if you walk into a company and don't quite get their mindset, you don't become part of that tribe.
You'll become if you are the classic, insert framework here, and you get dropped into a company and that is completely against the nature because you don't understand the culture, you will not, A, make friends or gather the trust of your organization, and 2, may not be there very long, quite frankly, if it's a mature enough organization.
And regulations do have a huge impact to your view of security. It's one of those few things people think, I know everything and all this stuff, and you walk in and all of a sudden the regulation actually contradicts some of your mindset and how you want to put stuff in there, but you can't go around it, right? And give a good example is PCI says you should encrypt everything, but in fact, if you went and encrypted a whole sporting goods network, it's going to be very expensive. But if you just limit it down to a small part, you're in a better place. So if you walk in and be flexible, you know how to go.
And what you see to the right here is just, again, the CIA triad based on a scale of 1 to 6, arbitrary number, and just a general heuristic of the differences between like a life sciences organization, big pharma, or even a sporting goods organization, how they measure or place value onto each of those facets is different. So let's kind of give some context into understanding the industry. Ironically, when this talk was first made in late 2019, we didn't actually have to talk about this much, or we had to talk about it. Now this is becoming more mainstream under 2020 and the
something
global
called, I don't know,
COVID-19.
Yeah.
So again, you have to understand this particular industry with life sciences in general. Every single new drug that comes out has, on average, in the United States, right, because countries differ, on average 15 years of scientific research behind it. And it's very much like a funnel where you start with gigantic data sets in drug discovery, and you're honing it down through preclinical and clinical trials, ultimately to regulatory approval and then into the market, right? And when I say massive amount of data, I'm talking order of petabytes, year over year over year, down to here's the compound, if it's a compound, not a biologic, here is the actual trials, that narrows it. But you have to keep the evidence chain, if I want to talk IR, right, through this scientific drug discovery process. Because of those regulatory factors coming back into play, you will have audit, again, talking kind of security, show me the evidence of scientific sound, or viability of this drug, right?
And so, then you have to keep all that data for the life of the drug.
So massive amount of data. You're coming into this organization going, oh gosh, at early drug discovery, you have research scientists who are really big in collaboration, and now go solve the world.
So here's an example of a scientific research company. We worked in them, and we worked in them. Also, we have a lot of friends in them. The great thing about the highly intelligent researcher cat is they love to collaborate. They really do. They are working with universities, institutes, research organizations.
Friends who are scientists.
Yeah.
Very passionate.
Yeah. And highly motivated.
Yeah.
You know, quite often there's a personal connection to some of the research they're doing. So when security comes in and says you need to stop something, you can think about it's almost like going to somebody and saying that baby is ugly, you know. Plus,
they've spent their entire career typically going for this particular area, right? Similar with security, like you are a really good IR guy or you're a really good blue teamer. They have spent their entire area saying, I'm going to do oncology low molecular weight study on this particular disease area because they're very passionate about it and completely motivated. And credibility. Credibility is huge.
And just like in security. And the interesting thing when you look at the credibility, there is a ton of scientific research papers out there. All of these life science companies actually have a really good process to actually release papers.
Publish, yep.
And you'll see that quite often in any of the company you work with. But when you get to a lot of it is these guys, collaboration is how research works.
And credibility,
yeah.
Right. So for you or anyone who's in security going into a research organization, this credibility is actually key, all right? Because you're going into a culture, you're going to bring security controls in, for better or for worse. You have these intelligent cats, you need to ultimately herd them. And this, believe it or not, is where you need to exploit, because to have conversations with scientists that you go, CIA, we need to do this for insert reason, and it's not in the language of them. If I turn to them and say, you've spent your career doing research into fibromyalgia, and I want to make sure that the integrity of your research is sound, not only for, you know, patients down the line, which they're very motivated and passionate about, but for your own credibility as well. That is the language that resonates more with your audience.
Yeah, and it's very interesting because one of the first interviews I had in a disease area with a scientist, he walked me into a room and totally drew out a molecule for me and literally asked me, what is that? And he was literally that moment trying to see what I knew. And I told him to his face, I have no clue what you're talking about. And after a few meetings, he said, well, the reason I asked you about that is because A, that is the tea molecule that you're drinking, and B, I wanted to see if you're full of shit, right? Which is great being a CISO and being told that. But honestly, these guys know so much, and they want to see your credibility. Are you honest? Are you open? What are you willing to share? You know, and that's how it moves forward. And back to that picture we just had, the integrity is key for these guys, right? Because if the integrity of the research they have done is
following
changed,
the scientific method, right?
Following scientific is changed, that can either put years of research down the tube, or
millions of dollars,
or when a paper is released, they lose their credibility and the credibility of that company.
That's why they're peer reviewed, right? So that kind of gives you into some of the mindset. Now, unfortunately, this video doesn't actually work for whatever reason, because I was trying to get it to work while you were talking and it's not. So there's a meme online where is the cat walking through the ever shrinking hole of, you know, a doorway.
Of security.
And if you just apply security controls on the top of it, that's pretty much your entire life, right? So you're going to apply security controls. They're going to find ways around it. This is why you care. You need to be able to have these conversations with scientists or users or anyone within your organization. All right, story time. So
a few years ago, we came back into the office after Christmas. It was wonderful. We all had wonderful holidays.
It was great.
And depending on which organization you're in, we're lucky that over the Christmas period, our company would shut down.
Most life sciences do, because they have to overhaul the lab environments.
So, you know, we came back in the office. We were looking forward to a slow start as always, and suddenly we saw this huge uptick on new traffic going through the network. And it wasn't just localized to America, it was global, going to different locations, different parts of the network. And we were, I'm not gonna lie, highly confused. So
puzzled.
Puzzled is a good word. Thank you, freshman. And after spending a few days tracking things down, and we started to see a very very clear adversary in our network. And the more we dug, the more we were shaking our heads, because first it was against our process, and secondly against our policy.
And this traffic was not happening during the holiday. It happened after.
Yeah. So, and you saw it increasing each day as more and more people came back to work. And the funny thing is it was in different labs, different locations, different buildings globally, and had us a bit confused.
So again, this is typically where we would ask the audience, if we're there in person, give us some ideas of what you think it is, right? And unfortunately, we can't quite do that. So if you want some theories or you want to put some guesses down into Discord, go for it. But at the end of the day, hi, Alexa.
Yeah. And people are like, why do they actually care about Alexa? Why would they bring Alexa into the organization? There were a lot smaller Alexas as well. Scientists want to also make their life easier.
So you're in a controlled lab, you're PPE'd up because say you're dealing with an infectious disease, relevant, right?
Yeah.
And you go and you're following a protocol for a research experiment. Hey, Alexa, remind me in 20 minutes to take the, to check the microscope or to take the lab samples out of, the cooker, right? It makes sense because they don't have to take off their PPEs, go to mark a timer to touch anything.
Yeah.
Or they can have Alexa do a quick research on particular, give me the actual molecular weight of insert a compound name here. Yeah. It makes sense from a business day-to-day lab scientist perspective.
Yeah. And honestly, we want research to go fast. We just don't want Amazon to know everything we're doing.
Listening to every single word. Yeah.
So, it was interesting because, like we said, partly it's ignorance, and secondly,
they assumed good intent.
Yeah, good intent, and it did help them. We had to stop it, and we felt bad about it. But these people tried really hard to
make a case. Yeah.
Make a case. Yeah.
So that was life sciences. So let's kind of take a look at the late pharmaceutical organizations, right? And in pharmaceutical manufacturing in particular, it's kind of its own edge case because you're dealing a little bit more with OT and ICS environments. So we'll kind of touch on that as well. But when you're getting into more of a late phase in human phase 3 trial before getting out of the market, you have to know regulations, you have to know requirements, you have to go GXP, good practice, God bless us. You have to have quality documentation. And on top of that, you as an InfoSec guru need to keep aware of mergers and acquisitions as well, intellectual property and intellectual property theft, as well as data classifications and secret projects that no one within their organization may need to know about. And it sucks, right? There's no good way to talk to a late stage pharmaceutical person to try to elicit a cultural change. There's no, it's fear.
Yeah, it really is fear.
It's horrible, but it is, because the availability of the drug to be available has to be super high. You have to get it out. The integrity of the formulation has to be 100%. And the confidentiality of the formula at that point, once you kind of get into OT, you're getting a little bit, we'll talk about that, has to be confidential, because as soon as you patent that information, you're now on a ticking time bomb towards generic land, right?
And also what's very interesting here is depending how much money you've actually had to invest into creating this drug, right? You
Millions or billions.
You actually have 2 windows, right? The window is 5 or 7 years, right? And you have exclusivity for the 5 or 7 years, depending how much money it costs to make that drug. So at the same time, you're making this drug, you're releasing this drug, you know that it can be de-engineered on one side of it, but on the second part of it, we need to constantly make sure it keeps coming out. Now, if you look carefully, big pharma care about everything, right? They care about their recipes, they care about
their
M&As,
brand, the M&As,
a lot like in the research organization, confidentiality isn't that important, because especially to the scientists, because
they haven't patented yet.
They haven't patented, but secondly, they want to talk about things, and it's really hard for us security guys to actually know what's secret, because a scientist may continue working on something that's amazing that may cure cancer, right? But nobody tells us about it until he's 100% sure, and it's gone through certain phases of the process.
Yeah. And so you're asking yourself, why the hell should you care, right? Why do they care? Why? Yeah, you need to stay off this list, right? So this is a list of contamination incidents with medical contamination incidences, or back, was it in the 80s or 90s? So there was a very, you tell the story.
I mean, the whole Tylenol case was a very high profile case, right? And what happened there is every one of the pharmaceutical company
Insert farmer here, yeah,
actually has to go back and validate and prove it could not have come
been them in their pipe,
in the complete pipeline, right? And it literally checking, everything gets turned off, stopped, and it's instant response
on a massive scale,
at a massive different kind of scale, right? And it's also a different kind of, you've got forensics for both technical forensics to understand was the machine changed, was code changed, and all this stuff.
Also scientific forensics as well, right?
Hence GXPs, good in-situ patches, you have to validate that. The quality guys, they're going through a complete
to kind of give you a sense of it, if something within pharmaceutical or life sciences is a good practice or a GXP qualified system, any change to that system, if it's even down to the change the wallpaper, and if you're doing a clinical study on that virtual machine, must then be wet inked or PKI signed, revalidated that the state of the machine, the integrity of the machine is the same, because it runs trials, right? Yeah. It is massive. So you're asking yourself, you got researchers who are collaborating, they're running around like crazy. You got pharma who's freaking out all the time, who, they really care about the CIA classification. What are you doing, right? You're cat herding. For lack of a better term, your job is to herd cats. And this was back in the 90s. It was a Super Bowl like half show commercial where it's the classic Western, and it's cats coming over the hill, and they're essentially herding cats at any one point. So let's give you kind of an example on how to herd cats, right?
So first off, you need to understand your audience. Comes back to understanding your audience.
Clower is a group of cats.
Yeah. Understand who you are, who they are, and how to interact with them. I mean, it's kind of interesting in the organization we worked in, when Big Pharma would come up with an awareness campaign, it wouldn't gel with our cats. Our cats would look at it and feel like they're being talked down to.
And culturally speaking, scientists may not necessarily identify that they're part of a major pharmaceutical, or say in the space industry, like scientists, our astrophysicists may not necessarily agree with working with like a government regulated company. And then instead of that, you take those, once you've understood them and you kind of understand, you exploit those innate characteristics or utilize if you're business friendly, right? So it's really about confidentiality. Use that, for lack of a better term.
Yeah, and they want to save the world, and you have to show them that the only way they can save the world is by
following some principles of the CIA, right? Don't ever become the enemy, right? They are stupid smart. So just, explaining or patronizing or not giving the reasoning why, assuming that they are less intelligent than they actually are. They are super intelligent, but they may not have the exact language term set or context space that you and your career may know. So don't become the enemy. Listen a lot.
Yeah, I mean, here's where social engineering 101 comes into play. Listen, read, and understand, right? Listen to what they're saying. Read the body language. Sometimes you'll get the understanding that you're talking and you can see that they're squirming. Doesn't mean that they're doing something wrong. They just don't understand it. And we've seen a lot of the times from a lot of these guys and girls is once we've come to a point of discussing the point, you've lost them.
Or conversely, terms will be overloaded within scientific realms versus IT security or OT security realms. So again, it's what do you actually mean by target? Because within information security, it means something completely different than, say, a chemist. And don't be afraid to ask that question, or ask the question, de-acronym it, right? Because it means that you're listening to them and you want to understand them, and you'll start building respect.
Yeah, and it's kind of funny because I was having a long discussion with a couple of them, and they started talking about ATP, and I thought ATP was an advanced threat protection. They were actually talking about
A molecule.
a molecule, and I'm totally thinking they're getting what I'm on about, but actually we were in a different universe.
And if you do this, so how do you deal with management, right? Like you're doing all this, you're listening, but the phrasing that you're actually using for upper echelons of management is that you're actually building a company-wide security culture. So this is kind of gives you the overall cover to do this, and like this is how we're affecting change within an organization. This is what we're actually doing. You know, security by design, privacy by design, culture starts here.
Yeah, and it's when you as you work through and you start building credibility within the different labs and different disease areas,
departments and everything else,
you'll actually see that people start coming to you, and it's very important with these guys to understand. I mean, we've had examples of these highly intelligent cats taking our HPCs to try and figure out
high-performing cloud environments.
Yes.
Keep going.
Well, the HPC environment,
high-performance computing, yes,
was internal, and we had a guy in one of our labs who had
cranking the CPU,
yeah,
like just burning thousands of CPU cores and then going away, right?
So our HPC guys came and said, look, we have a problem. We think possibly it's Bitcoin mining or something. We'll go look into it. So we went and looked into it. We came back, and the gentleman in this case was a really nice guy who had a few years ago found a
new prime number,
and got a little bit of notoriety from it, and wanted to find the next one. So he decided to crank up these expensive.
He had access to it. Let's go.
Yeah, and really expensive piece of equipment, and started to go
and write his own script and throw it out there. These are the types of situations where you're like, say what? That you come across day to day, right?
And it's trying to then communicate why this is not what's supposed to be done, right? But it's not a security incident at that time, right? After we figured it out, but now it's a management institute,
right? So I know we blazed through a lot, so we're going to kind of give you a little bit of a bonus example, and we're about halfway through, so we can actually give you some other anecdotal and then touch into OT as well if you really wanted to. So do you want to do the space one?
Yeah, so as you can guess, I worked in the space industry. Wonderful place. The funny thing is we were responsible for the network, and within this organization, I'm not going to say the name of the European Spacecraft Operations Center at all. And within this, we own the complete ground operations, the communications between the satellites, between the ground stations and the satellite controllers. We are literally in the middle. And it was a lot of fun. And one thing that I first learned at moving into the spacecraft industry is how old technology is. And if you see in that beautiful picture there is a beautiful, beautiful computer. Love it to death. If you look closely, there is a spot coming out of the side. Now, this computer is about, right now, 40 years old, right? Could be a little bit older. It's a Bull Honeywell station computer. Those things coming out of the corner, do you have any clue what that is? Outside of Christy, who has been in my presentations before. Now, 40 years ago, we also had liquid-cooled computers. It's not a new thing. Everybody thought it was cool. When they first heard about gaming computers that were liquid-cooled, I was like, really? No, that actually is the cooling, water cooling for that station computer.
Now, question. Do you think that the station is still in play today?
So before I left a few years ago, we actually built a station computer in software, right? First off, we couldn't run it in software because we couldn't find a processor slow enough to run it because it would go too fast. Yeah. So if you've ever played Wing Commander on it, you'll remember literally you go through the asteroid field like this and not get hit by one because collision detection wouldn't know. This would run too fast. So we had to build it and declock it because of how fast they run. Secondly, it was less than a meg, the size of the emulator we built.
And you have to understand with aerospace, right? you get one shot because you have age technology and satellites orbiting the Earth that are going to drop a payload, for lack of a better term, to receivers that are sitting and waiting, assuming you know where that satellite is.
Yeah, so it's very interesting with it is, like she said, when it drops the payload, it's cleaned its memory bank. So within the space industry during the biggest importance was availability and integrity. They didn't care about confidentiality, not because, you know, the thing is they had to get that data. Once that data was out of the satellite, it was gone. It would start doing its pitches or whatever and go round again, right?
What's the measurement for error? Like,
well, we would have to make sure that everything was set up back then anywhere up to an hour before, and then it's constantly sending signals to make sure you link on. The great thing about it is you have this window and your satellite goes like this, and then once it's out, right? So you try to get all the data. The other thing that's kind of interesting with satellites is, Stephen, today, most satellites are built. So if I build a satellite today for a satellite to release in 2 or 3 years a day, it's normally being designed with technology that's already 1 or 2 years out, right? There are satellites out there that know Windows Vista, you know, so, and some up there with you know, an old version of.
And these are hard time system. Like if you miss it by a couple of seconds, it is way over the, you know, workload.
And you know, the space industry, both NASA and European Space Agency, maybe not so much Elon Musk's one, but
they're new. It's fine.
You know, they all use old technology because the problem is that they have so much legacy out there, right? And
this kind of goes into the challenges with OT.
Yeah, which slides slowly over to OT.
Yeah.
Just think of OT in space. Yeah, sounds like a TV show. You know, but it's a very interesting dilemma for the spacecraft controllers, because if they don't have any data, the next thing they're coming to is the network team to understand where the data could get lost. And a lot of times now, now of course a lot of new spacecraft controllers have a good memory banks to keep a lot of the data for a while.
For redundancy, yeah.
But we used to run X25, which is a guaranteed delivery, right? And then even when TCP/IP came out, we didn't move across because we needed a guaranteed delivery of the data constantly.
So with some parallels into OT and manufacturing, right? So within drug discovery lab environments, these are, again, real-time systems, hard systems that are very bespoke, kind of like satellites as well, that are built on, at the time, it could have been decent to good operating systems. And there are 1 or 2 of these devices out there. So like a mass spectrometer, there's like 4 in the world. They're sitting on Windows embedded, if that. And they're qualified for doing drug research in humans, and you can't change it very much, right? So being able to make updates to it, you can't actually guarantee that the integrity of the information is the same. Also, that company that made these 5 or so pieces of scientific equipment might not be around anymore. They might have been bellied up for whatever reason, but the actual device is in a long-term study gathering information. So you have the challenges of, these are classic OT challenges, right? As soon as your product or your machine is out there in the wild, it's starting to deprecate and become more risky as far as vulnerability. But in a controlled environment where you can't touch it and it's sitting on your network. So thinking of how to be able to have compensating controls, kind of getting into a little more of the OT realm, is a constant challenge for us as well, as you have cats bringing in Alexas and crazy stuff, because again, super intelligent, they like technology. Let's bring some Google Glasses in here back in the day.
Oh yeah, we had Google Glasses for a while as well. But the other thing that steps out here is that you've got to realize that all the old technology within the different realms have different
purpose.
Yeah, have a purpose and different vulnerabilities that will never ever get patched, right? You'll have systems that have no clue what encryption is, or you'll have systems that need to drop a payload every 24 hours, and it's using SMB version 1, right?
And this goes back into, there's no one right fit size. Like, okay, we have these devices, we now must be GXP compliant. How do we do it? we ourselves are our own cats in this case, where we have to think laterally outside the box.
Yeah, and in a lot of times it's working very closely with the people, right? So if you go back to like looking at sporting goods companies, right? What do they have that's really important to protect, right? Sure, a marketing deck because they want to come first to market with a new shoe, and right? Oh, so the new shoe needs to be protected. But a lot of people don't understand that sporting goods companies like Adidas, Nike, Reebok, Keen, New Balance have actually really good research teams, right? They are creating new rubbers that are part of the shoe. You think that the base of your shoe is one piece of rubber, and in fact, depending on what you need that shoe for, that shoe may have 3 different parts of rubber in there for impact and for your heel and for the arch of your shoe, and it looks and feels exactly the same. And they've been spending 5 years creating this rubber, right? So it's very interesting that how all of these companies look and take the CIA principle. I mean, working for a research company, golf heads, have a lot of research that goes into
golf club heads.
Yeah,
yes.
have a lot of research that go into them. And you sit down with some of these people who are looking at different metals. They're getting boutique metals brought in to try and see if a little bit of this compound will actually change the way that the metal will resonate and bounce. So it's a very interesting way that things move.
So we have about, wow, we blazed through that.
We did.
So we have about 10, 15, 20 minutes-ish. Any last anecdotes that you have for the audience?
I mean, it's very different in each one of these fields of what you have to do, right? To me, the thing that got me further through all of this is understanding social engineering. Yeah. Learning to read people, because honestly, when you're sitting and talking to people who are seriously smart, most time, I'm not gonna lie, everybody that I've met in this industry is smarter than me, right? And I have to understand what they're trying to communicate to me. It's confusing, it's technical, but it's the same way when I start getting technical with them about security. I will walk into a meeting with somebody and the scientist will go and start going, la, 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 databases, la, 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 internet, right? And I have to figure out, they want to put their databases on the internet, right? Or I don't get it. But this is where working with them, understanding and building a lot of the, credibility that they actually are also looking for.
You're establishing trust.
Yeah.
Trust via social engineering, active listening, and clear communications.
Yeah.
Which is tiring, right?
Yeah.
But it's sorely needed within our industries when you're actually in a position where you need to protect an organization.
Yeah. And it's always phenomenally interesting in any one of the organizations that you work in, that if you take the time to watch people and listen to people, you'll understand the organization a lot better, and I tend to do all my meetings in a cafe, so they don't feel like it's in a meeting room, or it's also trying to get their trust and relaxation. Somebody's relaxed, you're in a better place.
If people trust you and they're relaxed, this is more of the risk manager in me, right? And they identify risks or concerns, they will approach you and your team sooner than later, right? So this is I got a question, but I just downloaded this public data set around these clinical studies and I don't quite know what to do because it's now been mashed up and I'm dealing with PII. And I'd rather have these conversations sooner versus later. And historically, with regards to just any sort of a research organization in general, as soon as you hear security or information security, right, there's a stigma that we as professionals need to break, so that one, we're approachable, and two, we're here to help you employee within the business, do what you need to do, right? We're your meat shields, for lack of a better term.
Yeah, yeah. And as you can see from a lot of it, it's every one of these companies uses the CIA principle
implicitly, but without calling it out, right?
Yeah, and at different values.
Yeah.
Right. You know, it's important for a pharmaceutical company to protect their
everything.
Yeah. You know, their M&As and what. But that's not saying that research companies don't do M&As. They do targeted M&As for different things as well. But it's not
figuring out risk posture.
Yeah.
Right.
You know, for them, it's also a level of we'll do one M&A, whereas the pharmaceutical company will do 30 M&As in a year. Right. Or a sporting goods company will decide to come up with a shoe. I mean, if you look at the Adidas One, every company out there was doing the Adidas One research, right, to come up with the intelligent shoe. Nike was doing it internally in Keen and
all of them. Right?
Yeah, the shoe was not amazing, but
everyone was doing it.
Everybody was doing it, but it was just to be the first company out there. So it was like top secret projects, like in pharmaceutical companies, they have these top secret projects.
And once you learn the CIA principle for an organization, you can then have conversations with upper management. Because again, going back to the earlier slide, which I'll probably pull up in a second, one of our nightmares is budget.
Yeah.
So during a time where it is, global pandemic and your budget's this big, right? How do you effectively convey to those who are going to grant budget the controls that you need to put into place, or the technologies that you need to put in place for your information security program that's in line with the risk posture, the CIA posture of your organization.
Yeah, and you can only so many times lean on regulations.
Yeah.
Because it comes to the point where unless regulations haven't changed at that time, you can't lean on it, because in theory you should already be regulated and in the right place. Otherwise, you could stop research, you could stop a drug, right?
Yeah.
So when you walk into those rooms and you're talking to senior management
who have no experience or knowledge within information security.
Yeah. You're leaning on in like research integrity, right? Guys, we need to make sure we want to do a data classification project because we need to
we need to know what to protect.
Yeah,
All right. So with that, I'd like to thank everyone for attending. Sorry that we rambled and went a little bit too quickly.
Yeah.
Again, so I'm Red. This is Silent Shot. If you have any questions, feel free to follow us on Twitter. We're happy to answer. Again, if you'd like this slide deck as well, a big shout out to Dave Reynolds, who actually designed it for us. Fantastic person as well. Again, questions, feel free to put it in Discord. We're really appreciative of Circle City to have us.
Yeah.
And then we'll give everyone a few minutes to take a quick break before the 2 o'clock show starts.
And I would definitely agree with Cthulhu, who says a lot of the scientists do have and they have great IT skills. They code as well.
Yep. They will just throw information in data sets, not necessarily following good practice at all, or even design patterns, because they are gigantic scripters at this point. Get the data to it. Let's go. Don't care how dirty it is.
Yeah. So, or they get a tool, they'll write a code to make the front end of the tool look better because they didn't like the color of the other one.
Or they'll buy a tool and just intersect it into their laptop, right? Like it is what it is.
Yeah.
Awesome. Well, thank you all, everyone. We really appreciate it, and we look forward to chatting with you offline.